Welcome to the DIY Honda Garage channel. Today we are addressing DTC P0714, which signifies an intermittent failure in the continuously variable transmission, CVT, fluid temperature sensor for the Honda Fit models from 2015 to 2020. This diagnostic trouble code illuminates when there is a problem with the electrical circuit of the temperature sensor, rather than indicating a mechanical issue within the transmission itself. Essentially, the CVT fluid temperature sensor monitors the fluid's temperature, ensuring the transmission operates efficiently by preventing overheating or damage. Located within the transmission assembly, this sensor plays a pivotal role in providing accurate data to the powertrain control module, PCM, and the vehicle's diagnostic system. It's imperative to understand that this code may present in various states, including confirmed and pending DTC. Our focus today will be to troubleshoot this code systematically to ensure the proper function of the CVT system. DTC P0714 relates to an electrical circuit issue with the CVT fluid temperature sensor. This failure indicates that the sensor is unable to relay accurate temperature readings, which could hinder the performance of the transmission system. It's crucial to stress that this code does not stem from mechanical problems within the transmission, but rather from the sensor's inability to function correctly due to electrical issues like short circuits or poor connections. The CVT fluid temperature sensor is typically located within the transmission assembly, adjacent to where the transmission fluid circulates. Its job is to monitor the fluid's temperature, providing valuable input to the PCM. This, in turn, influences various transmission system adjustments to optimize vehicle performance. Understanding the possible causes behind DTC P0714 is essential for effective troubleshooting. The most common issue is an electrical circuit problem, which means there could be issues with wiring, connectors, or other electronic components affecting the signal to the PCM. Additionally, the temperature sensor itself might be faulty. This failure impacts its ability to provide accurate readings. Poor connections or loose terminals between the transmission fluid temperature sensor and the PCM can lead to intermittent failures, resulting in this diagnostic trouble code. Each of these causes can lead to miscommunication in the system, leading to possible damage or inefficiency in the transmission if not addressed properly. Identifying the symptoms of DTC P0714 can guide a technician in diagnosing the issue. Drivers may experience erratic transmission performance, which can manifest as unusual shifts or slipping during acceleration. Another sign is poor shifting behavior, where the transmission hesitates between gears or behaves unpredictably. Additionally, the check engine light is likely illuminated on the dashboard, signaling an underlying issue that requires attention. These symptoms can affect overall vehicle performance, potentially leading to costly repairs if not addressed promptly. Recognizing these signs early can help in pinpointing the problem before it escalates. The first troubleshooting step for DTC P0714 involves checking the continuously variable transmission fluid, CVTF, temperature. To commence, turn the vehicle to the on mode without starting the engine. Utilizing the Honda Diagnostic System, HDS tool, examine the current conditions and compare the CVTF temperature against the engine coolant temperature sensor, ECT, reading. Ideally, both temperatures should equal the ambient air temperature. If they do, it indicates that the sensor readings are consistent with the environmental conditions, suggesting the system is functioning correctly up to this point. Should temperature levels vary, it necessitates documenting the CVTF temperature for subsequent steps. This process allows us to establish a baseline and determine if any irregularities exist. For the second troubleshooting step, we need to check the transmission fluid temperature difference. Start by turning the vehicle to the off mode and allowing it to sit for at least 30 minutes. This wait is important as it allows the system to stabilize and can help in providing a more accurate temperature reading. After the waiting period, turn the vehicle back to the on mode. Utilize the HDS tool again to compare the current CVTF temperature with the value recorded in the first step. If the temperature reading has changed significantly, it indicates a possible issue with the sensor. If there's no change, it suggests that the sensor may be faulty, leading to the needs for replacement. This step is critical in understanding how the sensor is responding to temperature over time. The final step involves checking the values of the CVTF temperature against those recorded for the engine coolant temperature sensor, ECT, in the HDS data list. By comparing these two readings, we can identify discrepancies that may indicate sensor failure. A key indicator is if the CVTF temperature exceeds the ECT sensor value by 58 degrees Fahrenheit, 32 degrees Celsius, or falls below by 43 degrees Fahrenheit, 24 degrees Celsius. If this occurs, the transmission fluid temperature sensor is deemed faulty, necessitating replacement along with the solenoid wire harness to ensure a clean electrical connection. However, if the temperatures are within normal limits, the sensor may still be operational, leading us to consider that intermittent failures might be caused by poor connections or loose terminals. In such cases, further inspection is warranted to secure electrical integrity. After completing the troubleshooting steps, a final repair verification is essential to conclude the process effectively. First, verify that all connections relating to the CVT fluid temperature sensor are secure and free from corrosion or damage. This is crucial as poor connections can often lead to intermittent failures, even with a new sensor installed. Next, recheck the transmission fluid temperature to ensure that it is within the acceptable range. Confirm that there are no outstanding diagnostic trouble codes related to the DTC previously observed. Successfully clearing the check engine light while ensuring the vehicle operates smoothly signifies that the repair has been effective. This thorough confirmation step is vital for restoring confidence in the vehicle's performance. Engaging in routine preventive maintenance can significantly reduce the likelihood of encountering DTC P0714 in the future. Regularly check the transmission fluid temperature as a part of routine vehicle service to catch potential issues early. During these checks, inspect the wiring and connections related to the CVT fluid temperature sensor as well. Any signs of wear, corrosion, or damage in these components can lead to future electrical problems. Additionally, ensure that the vehicle's software is updated as necessary, as manufacturers may release updates that enhance sensor performance or address known issues. Adhering to these practices helps maintain optimal function and longevity of the vehicle's transmission system. In conclusion, understanding DTC P0714 associated with an intermittent failure of the CVT fluid temperature sensor is key to effective vehicle management. It's imperative to approach the troubleshooting process systematically, ensuring each step is followed to identify the exact cause of the issue. This includes checking temperature readings, documenting changes, and securing all electrical connections. Conducting regular maintenance and monitoring sensor performance can greatly reduce the likelihood of encountering similar issues in the future. By prioritizing these practices, owners of the Honda Fit can ensure the vehicle operates efficiently while enhancing safety and reliability. Remember, the CVT system's functionality is paramount for overall vehicle performance, and addressing these codes promptly is essential. Please like and subscribe to the channel. See you